Alright, let's start today. Start by training this. Oh shit. Choose low. I need to increase my accuracy. It's quite addictive to do this actually. So I'll come back to this later. Gotta be honest, I remember doing this, searching for this challenge here, which is the one that I stopped on the last day that I streamed. I think I can do like this. No, I can't. Title. Yeah, rating, movie, IMDb rating. I got the thing. Undefined is not a function. If I delete this, it's probably because I didn't do anything here. So, movie, turn, parse float. This is rating, not raging. Yeah, maybe this needs these brackets too. Something is wrong. Maybe it's rating instead of movie, yeah. Let me see. I doubt that's the way, but yeah, that's not it. So from what I understand from map, the movie is gonna take the value of each one of these objects here and it's gonna loop through the whole thing, and to every object, to every value of the object is gonna apply this and return this. This one's gonna be the title, and this one's gonna be the movie, the rating. And let me comment this out and see what's happening. Yeah, so it is returning. So the part that's wrong is probably the filter one. Oh, I forgot to put the condition here. Oh, dumb of me. 0.0. Still not returning anything. I don't understand why this doesn't work as well. I'm just gonna look it up. Yeah. That doesn't make any sense to me. There we go. Now it works. So what was wrong was the specification. I was taking the specification from the watch list, but the right way is to specify inside the array you just created, the object we created on the map function. Didn't I just did this? Didn't just do it? I remember this exercise. Close this door. It's noise. So this should filter as I forgot to choose for each. I have a feeling this is wrong, but didn't use this on that solution. No, I forgot the for each. Why does this doesn't work? page put elements here. There we go. Okay, so it's first three that I want. I feel like this challenges should be before all the other sections, where I had to use most of them to solve the problems. Now it's time for the big one. Hello, doing some pre-code camping. Pre-code camping, yeah, doing the challenges. The pre-code campsites. I need to use map and filter first. Nice.
tal botar a dor pra correr? Para dores de cabeça nas piores horas, chama a Neuza. Neuza!
Once again, with our array of numbers, let's say we want to calculate the sum.
Right back. Let's keep going.
Sum of all these numbers in this array. This would be similar to calculating the total cost of all the items in a shopping cart. So each numbers here would represent the price of an item in a shopping cart. Of course, we wouldn't have a negative number there, but you got the point. So here's a very simple algorithm for calculating the sum of all the numbers in this array. We start by declaring a variable called sum, and we initialize it to 0. Next, we loop over this array, get each element or each number, and add it to sum. Something like this. For let n of numbers. Now we want to add n to sum. So we can write an expression like this. Sum equals sum plus n. Or a better way is to use the addition assignment operator. So we can exclude this second sum. So this is exactly like the statement we had before. And finally, we display sum on the console. So we get 5. Now there is a cleaner and more elegant way to write the same code using the reduce method in arrays. So all these arrays have this reduce method, and with this method we can reduce all these elements in an array into a single value. That single value can be a number, it can be a string, it can be an object, it can be anything. In this example, we want to reduce all these elements into a single number. That is the sum of all the numbers in this array. So let's see how we can use the reduce method. This method takes a callback function with 2 parameters, accumulator and current value. So here I'm using an arrow function like this. This accumulator parameter here is exactly like this sum we have here. It's something that we initialize, and then this callback function is executed multiple times. Each time, this current value will be set to one element in this array. Okay? So in each call, we want to get this current value and add it to accumulator. So we simply return the sum of accumulator plus current value. Now internally, this reduce method will get this result and store it in the accumulator. You'll see that in a second. And one last thing we need to do here is to initialize this accumulator to 0. So as the second argument to the reduce method, we pass 0. Note that this reduce method has 2 arguments. The first argument is a callback function, and the second argument is the initial value for the accumulator. Finally, we get the result as a single value, in this case, sum. Now we don't need this code anymore. And finally, let's bring this console.log here. Save the changes. You can see we get the same result, 5. But let's see what exactly is happening here. So initially we set accumulator to 0. So I'm going to set a equals 0. In the first round, current value will be set to the first number. So c equals 1. Now we add this together. So we get 1, and a will be set to 1 after this callback function is executed. So
the first argument is the accumulator. I'm gonna get the rating. Doesn't make any sense.
As a result, a will be 1. Now in the second round, a is 1. Current value will be set to the second number in this array, so -1. And once again, we add them together. A will be 0 after the second call. Now the third call. So a is 0. The current value is going to be set to the third element in this array, so 2. And as a result, a will be 2. And finally, in the last call, we start with a set to 2, and current value will be 3. Okay, so the result will be 5, and that's why we saw 5 on the console. So essentially, with this reduce method, we start with an accumulator, then we loop through this array and convert all these elements into a single value, which is in this case, accumulator, or the sum of all the numbers in this array. Now we can make this code even shorter. We can exclude the initialization of the accumulator, and with this, accumulator will be set to the first element. So let me show you what will happen. A will initially be set to 1, and current value will be set to -1. That is exactly like our second call here, right? So as a result, A will be set to 0. Now, in our second round, A will be 0, and current value will be 2. Because in the previous call, current value was here, so now we're here. So current value will be 2, and as a result, A will be 2. And finally, in the last call, A will be 2, and current value will be 3, the last element in this array. And once again, we get 5. So if we supply an initial value, we'll have one more call. If we don't, the first element in this array will be used as the initial value. So this is how the reduce method works. And finally, to make this code a little bit shorter, we can get rid of this return keyword because we have a single line and we are simply returning a value. So remove the return, the semicolon, and the curly braces, put everything on a single line like this. So with this single line of code, we reduce the numbers array, and this is how our reduction algorithm works. We simply get the current value and add it to our accumulator. This is far cleaner and more elegant than declaring a sum and then looping over this array, like let n of numbers and then add n to the sum. That's a very old way of writing code. Hi guys, thank you for watching my JavaScript tutorial. This tutorial is part of my JavaScript course where you will learn all the essential JavaScript
Why that score?
Understanding data structures and algorithms is difficult. Don't worry, Log2Beast can.
In this JavaScript coding exercise, we're going to walk through how we can get the average from an array, and we're going to see how we can leverage some functional programming mechanisms in order to do that. So if you have an array, something like this, what I want to be able to do is to take any number of values, add them up, and then divide them. So if you're a little bit rusty on your 6th grade mathematics, then the way that you get an average is by totaling up each one of the values. So we're going to grab the sum of the array, and then we need to divide that sum by the total number of elements. So in this case, it would be 3. And so the average of this specific array is 2. And we're going to see how we can perform this process and do it in as efficient a way as possible. So if you are following along and you want to actually learn this and really work through it, what I highly recommend is that you pause the video right now and you go and you try to build this out yourself. And then afterwards, come back and then watch the solution that I personally built out. So now in my solution, this is the way that I personally do that. Now there are a number of ways to get the average from an array, and I don't want you to use any third-party tools or any kind of mathematics library in order to do this, because I want you to understand how to work with a collection and then how to perform computations on it, because this is going to be something you're going to need to do in coding interview exercises and also just in your day-to-day development. So if you were to ask me how to get the average from an array in JavaScript, what I would do is create a function called getAverage, and I'm going to use a arrow function for this, and it's simply going to take in a single variable argument. So I'm going to say I want to accept an array as an argument, and then I'm going to use an arrow function. Now inside of here, this is where all the magic is going to happen. This is where I'm going to create a sum that's going to tally up all the values inside of the array that got passed in, and then I'm going to divide it by the length. Now there are a number of ways you could do this. You may have done something, if you tried to do this yourself, you may have done something like this, or you created a variable where you kind of tried to keep track. So you might do something like const I or total, or something like that, started it off at 0 and then said array for each, and you created some kind of for loop, and then from there you tried to tally up each one of the values. So you said total, and then you incremented that total by each element, and that would have been a perfectly fine way of doing it. And if you got the answer where you're able to create your sum and then create your average, then that's perfectly fine. And I would not say that that's a wrong way of doing it whatsoever. But what I want to do is show you a different way of doing it. I want to show you a functional way. So I'm going to use a tool called reduce. And so this is a function specific to JavaScript. And before we even get into that, what I want to also walk you through, because when it comes to these solutions, it's really, to me, the goal is not just to give you the answer. That'd be pointless. If that was really the case, I would give you the different instructions, and then I'd just send you the solution and just post that, and that would be all there was to it. To me, there's no point in that. I want to impart to you the way that I personally would walk through the solution and how I would see other professional developers do it. And so if I were to give myself or some other developer that's experienced this exact problem, what I usually would see them do, and what I do personally, is walk through their solution without actually getting into the code. So I would do something like this. If I was told to get the average inside of it, I would write some pseudocode. So I'd say, okay, the first thing I need to do is I need to sum the values from the array. So right there, I know the first step. Then from there, I need to get the length of the array, and then I need to divide the length, or the array, I should say, the array sum by the length. That is right there with those 3 lines. That is the pseudocode for this program. So this entire program needs to first sum the values, then get the length, and then divide the array by that length. Now, something that I have seen, and this is a very big distinction between experienced developers and new developers, not to say that there's anything the matter with getting into this, because I remember when I first started developing, I struggled through a number of different problems. And what I saw was when I was younger and I started to try to build out solutions like this, I would just stare at the screen for a little while, and that really did not accomplish anything. And one thing I noticed when I started paying attention to the experienced developers I was learning from was that they very rarely simply stared at the screen, but instead they would do things like this. They would write out the process, even if they weren't writing code. They would say, okay, I want to do this first, then I want to do this, and then I want to perform this other task. And what that does is it gives them a mental framework for being able to build out the solution. So let's first take this first process, and I'm going to even separate these out just so we can really have a really nice distinction on how to build this out. So the way I'm going to sum these up is I'm going to use the reducer process. So I'm going to say const reducer and set this equal to a function. So I'm going to say total and then current value, and I'm going to use an arrow function for this where I just say total plus current value. And just in case you're wondering right here, this is just some boilerplate code, and these names are not special. I want to be very clear whenever I'm working with special reserved names and when I'm not. So if I wanted to, I could say that this was X, and this was Y, this was Z, and this tallies the total plus the current value. Now what we're going to do with this reducer, now that we've created it and we've stored it in a variable, we're going to create another variable here called sum and set this equal to r, which r right here is just whatever array we pass in to get average. So I'm going to say r.reduce. Now reduce is a reserved word. So reduce is a function that is available to the array class inside of JavaScript. So any array you can call reduce on. And what reduce does is its argument is a function. So you need to pass reduce a function. And so let's actually look, if you're following along with VS Code, you may see this as well, where it says a function that accepts up to 4 arguments. The reduce method calls the callback function one time for each element in in the array. So it calls a specified callback function for all the elements in an array, and the return value of the callback function is the accumulated result. Now, if you are not familiar with reduce or JavaScript, or if you're not in the practice of reading documentation, that may all have sounded like a weird alien language. So let's walk through an example of exactly how this works. So all you have to do for reduce is you pass it in a function. So remember, we just created this nice reducer function. So let's see, and I'm not going to save this. If you follow me in a lot of tutorials, you may notice I do this a lot, and it's because I'm in the habit whenever I'm working on my own applications to save the file constantly. But right now, I'm not trying to save the file because I simply want to show you the output. So if I create some kind of an array, so if let's say that I create get, so I'm going to call get average, and inside of it, we'll use our example of just 1, 2, and 3. Oh, and actually, let me call it like this, and it says undefined. So, it's because I need to return this. That would be helpful. So there we go. Okay, so now we get 6. How in the world did we get 6? Well, let's walk through it. We created a reducer function here. That reducer took in a total and a current value. Now, the thing that's kind of weird about this, if you've never seen this before, is you may have noticed we're not passing in a total or a current value. That's what the reduce function does. So when you pass in a function to reduce, it expects this kind of setup where you're passing in the first argument is what is called the accumulator. So what it does is it accumulates the value. The second argument here is going to be whatever the current value is of the array that you're working with. Now, if you're still confused, let's actually get rid of this. So I'm going to say, I'm not going to pass in this weird reducer thing that I just created. I'm going to grab all of these values, and let's just paste this in directly. So I'm going to paste in a total and a current value. So I'm passing in these arguments, and then I'm performing the exact same task. So I can even get rid of this here, and you can see down here that we're still getting the same value. So what reduce does is it's taking in that total, it's using that as the accumulator, which means that it accumulates. With each time that we go through, it's going to take the current value, and then it's going to add it to the total. Now, if you still don't believe me, let me add onto this list. So I'm going to say 3, 4, and 5. Now notice here that we're adding it up. So now we're at 15. So it is taking each one of those values. So if you add each one of these up, this does equal 15. Now reduce is not limited to doing sums. If that was the case, that wouldn't be very helpful, because then we could just call a sum method and it would take everything in. But it has to be more flexible than that. Imagine that we switch out this plus sign with a multiplication symbol. Now you can see on line 10, it's switched. The value is now 120. So this accumulator here, this total, is taking the current value and then it is now multiplying it. If I switch it back to the plus, you can see that it's back at 15. Let's walk through exactly what's happening here. When we start, we're starting with a total, and let me make this a comment so it doesn't give us an error. So the total when we start off is 0. And then from there, we're going to take that current value. And in this case, when we're passing this in, the current value is 1, just like we see it right there. So that's the first time. Now we add 1 plus 0. Well, we know 1 plus 0 equals 1. So that's now the current value total. So the next time we go through, so what reduce does is it iterates through the entire collection. So now it keeps track of that total. So now the total is going to be 1. And that current value, because we're now iterating through, now we're at 2. So the current value is now 2, which means that the return value is going to be 2 plus 1. So it's going to be 3. And then the next time, it's going to...
So why does this doesn't give me?
going to be total, which means our new total is going to be 3, because that's what the return value was. It's accumulating, and then the current value is now going to be 3, and as you may have guessed, it's going to tally up 3 plus 3, be 6, and then it's going to continue on from there. So it iterates each time. So it's going to be just like you created some kind of for loop or something like that. It's going to keep track of that value. It's going to loop through, and it's going to keep on adding on. And it's going to be adding on in our case, but it also could be multiplying, it could be dividing, it could be doing anything you want. You can have this function be very flexible with whatever process it is, and it'll just keep track of that value. Now, I'm going to create our reducer function again because I think it's a little bit easier to keep track of it. So I'm going to say reducer equals, and then I'm just going to take these values again, and then paste it up here. And now I can just pass in reducer. This is one of the reasons I love JavaScript, because we can pass in we can store entire functions and variables and then pass them in just like we're doing right here. So there's no difference between the code we used to have and what I have here. This is just a little bit easier to read and keep track of and also make changes still. So now that we have that, we know this is working. So right now, it's almost kind of like we have a sum function. This is going through and it's returning the sum. So if you notice, we have everything we needed for step 1. Now we need to get the length of the array. Well, how do we get the length? Well, we could, let me get rid of the sum. And if we wanted to, we could just say return r.length. And this is going to return 5 because there are 5 elements in the array. So that is what we're wanting. We now know how to get the length of the array. Now we don't want to return this, so I'm going to move this down and so move it into the next step. So I want to divide the array sum by the length. So I can do that by just saying sum, which is our variable, divide it by the array length. And as you can see right here, we have our entire working program. So we now have the ability to come here and get the values that we want. We have an array of 1, 2, and 3. That returns the average of 2, which is the correct average. Now, if we were to add any other values, so just a bunch of random numbers here, you can see that the average keeps on updating, and that is perfect. So if you take the values, if you take a list of 1, 2, 3, 23, 4, 5, 21, 34, and 5, it returns the average of 272.125. So our function of getAverage is working perfectly, and we're leveraging a number of different programming components here. We've built an arrow function, then we're calling it. We have created a reducer, and we're using the reduce function. So we're passing our reducer into reduce, so we're accumulating the value. That's how we're creating the sum. And then from there, we're just taking our sum and we're dividing it by the length. So I hope that if you went through this, that the solution makes sense, and it helps to give you a little bit of clarification on what functions like reduce and some of the functional components of JavaScript do to help you understand how you can apply it to your own programs.
Hello friends, welcome back. Today we're going to use the reduce method to analyze data. Array.prototype.reduce, or simply reduce, is the most general of all array operations in JavaScript. You can solve almost any array processing problem using the reduce method. The reduce method allows for more general forms of array processing, and it's possible to show that both filter and map can be derived as special applications of reduce. The reduce method iterates over each item in an array and returns a single value. Example, the string number object array. This is achieved via a callback function that is called on each iteration. The callback function accepts 4 arguments. The first argument is known as the accumulator, which gets assigned the return value of the callback function from the previous iteration. Which gets assigned the return value of the callback function from the previous iteration. The second is the current element being processed. The third is the index of the element, and the fourth is the array upon which reduce is called. Okay, so we might go back to this because this is really important, and it's also, when you first read that, that's probably impossible to understand. In addition to the callback function, reduce has an additional parameter which takes an initial value for the accumulator. If the second parameter is not used, then the first iteration is skipped, and the second iteration gets passed the first element of the array as the accumulator. Again, this is useful to understand. It's very important to understand, but it's probably difficult to understand just from that description. See below for an example using reduce on the user's array to return the sum of all the user's ages. For simplicity, the example only uses the first and second arguments. So, yeah, so for simplicity, they're just using the first argument, so they're using the accumulator, and they're using the current element. So the accumulator, so the sum is, I guess they're starting, so they're creating a thing of sum, and then they're doing a user for each element in there. So each user, so each time we come this. So user.age, so sum is plus or equal to user.age, and then they're 0, which is in the second element. The third element is the index of that element, and the fourth is the array upon which. So there's not a fourth one being called here. No, wait, that's not right. Comma 0. I'm not really quite understanding. So here's another example to see how the object works. The users, we're users.reduce, the object and the user. So we're being passed in the accumulator and then the user object, we return that, and then the last one, we're returning a object. So the variable watch list holds an array of objects with information on several movies. We want to use the reduce function to find the average IMDb rating of the movies directed by Christopher Nolan. Recall the prior challenge how to filter data and map over it to pull what you need. You may need to create other variables and return the average rating from the getRating function. Note that the rating values are saved as strings in the object and need to be converted into numbers before they are used in any mathematical operations. Okay, great. Let's go to the top. Look at this. Here's the watch list. It's got a list of movies in it, just like we've seen before. And we've got our average rating. Okay, so I'm just going to keep this average rating to the side for now. Let's start by figuring out, I like using let. Let's let Nolan movies equal to the watch list and filter. So the first thing we're going to do is filter out all the movies that aren't Nolan movies. So we want to filter based on the movie. And again, I'm going to do this in old school JavaScript, and then I'm going to refactor at the end of the video to use ES6 arrow functions. And so we want to filter the movie, right? So we want to say if movie.director is equal to Christopher Nolan, we want to return the movie. Cool. Okay, so now if we return Nolan movies, we're going to have a list of Christopher Nolan, movies, Christopher Nolan. We should only have Christopher Nolan. Okay, so now we have a list of Nolan movies. This is helpful because we could also go, now we want to let Nolan movie count equal Nolan movies dot length. And if we were to go Nolan movie count, we got 4. So there's 4 movies by Christopher Nolan supposedly in here. Okay, so Avatar wasn't included in there. There's 1 from Nolan. There's 2. There's 3. There's 4. Okay, so there's 4. Yeah, so Nolan movie count is working. So now what we really need is, well, we could say this is going to be equal to a number divided by the Nolan movie count. And so we can keep this as, what was it? Yeah, the average rating. So this way we're not changing the code below this line. So average rating, okay. The average rating is going to be whatever. So the sum of all the Nolan movies. Let's put Nolan movies back in here for now, just so we can see. Well, the next thing we want to do is, yeah, we should just reduce the Nolan movie. So yeah, we'll let the sum Nolan movie sum rating sum is equal to Nolan movies dot reduce, and in here we're going to add we're going to start a function with the total and the movie. And here we're going to, because it's a reduce function, I brought this up here. This is the JavaScript. This is how they actually teach it. So you want to do a function with the total, current index, and array. For this, you don't need to pass in these, and since we're not going to use them, we're not going to put them in there. But we could if we wanted to. The total, the movie, the current index, and the array. We don't need them, but I'll refactor the code later. So for now, I'm just going to take the total, the current, we've got a function, and then the initial value. We want our sum, we want to start with an initial value of 0. And what we want to do is take the sum, or the result, is equal to, we want to let the result equal the, no. We can just go total plus equal the movie dot IMDb rating, and we're going to say parse float. So we're taking the string and turning it into a number, and then we want to return the total. Okay, so now let's put Nolan movie sum into here so we see what's going on. 34.7, that's the rating. Okay, so that I think is correct. Yeah, so this is the sum of his ratings, and this is his count. Okay, so let's change this back to average rating, and then we want to let average rating be equal to the Nolan movie rating sum divided by the Nolan movie count, because the sum divided by the count is equal to the average. So the average rating is equal to that. And there you go. I think that that's the right answer. Okay, and I just, so yeah, let's run the test and see if it passes. Awesome, it passes. Okay, cool. Before we move on though, I'd like to kind of go back through and think about this. We can change these to arrow functions and clean up our code, right? So this would be a way, this would work the exact same way. As long as we keep getting this 8.65, our refactoring has been successful. With this if statement, there's no real reason not to just put this on one line here, because that just makes it look a little bit cleaner. And yeah, I think it makes more sense this way. Nolan movie rating sum is equal to dot reduce. Okay, well, we could use arrow functions here as well. And it doesn't make much of a difference there. Now, we use the parameters total and movie, but we don't need the current index or the original array because we're not using them. And we'll run into places where we use those in reduce, but we don't need those now. So we can factor that back and make our result look even better. Now, I actually like the way the Nolan movie count is created after we've got the Nolan movies, because yeah, we actually need to have the Nolan movies here. We need to have all the movies that he has. One thing that you could do is you could do map and then just take all the objects from there. And that might be a quicker way to do it, but why? Like Nolan, the number of movies that he's going to make are there's only so many movies that are going to fall into this category. So why not, even if somebody's a super prolific movie maker and they made 1,000 movies, it's still going to be too small programmatically for it to be expensive to calculate. So I don't see why we would want to do anything else to that thing. I mean, here, first off, we're iterating through the whole watch list. And so if the watch list was huge, this would take a while, but at the end of the day, there's not really anything we can do to stop that. So then once we get this, we're going to have the small number that we're going to reduce from, where we add to the total and we do the float. Yeah, we just add each of the sums of the movies, right? So the IMDb rating was 8.6 here, and then here the IMDb rating was 9.0, and so we just added all of those together, and we returned the total, and we started at 0. That's how reduce works. And then, so now we've got the count, and then we've got the sum. So sum divided by count is average, so average rating. And because of the nature of this, I would say get Nolan movie rating. Yeah, get Nolan. This I would say, if I were refactoring this for real, I would say get Nolan directed movie rating average. Some people don't like this and they think that this is a sign of bad code, but I disagree. I think that saying get Nolan directed movie rating average is better than just misnaming the function. And so the watch list is here, and then we get the Nolan movie. I'm not sure if that'll break the test. That does break the test, probably because of free code camp just once has the setting there. So we don't want to refactor this because that causes it. So we can't solve the test, but that's how I would refactor this if I were doing this in production code. And I don't really see any other opportunities. We want to just be able to quickly count there. I mean, we could, instead of we could just do this. That would be a way to make our code a little bit shorter. And I think that that's pretty readable. Anybody who knows programming is going to know how to do a dot length on the movies. And so we've got Nolan movies specifically laid out. And then the sum, yeah, we can't get this any easier than that. But I do think it's smart to have the average rating and show how we get that by having a count of by summing up the averages, and then by summing up the ratings, and then we divide that by the length of the movies. So how many movies are in there. And so yeah, I think that this is a pretty smart way to refactor this down. And so if we run the test, it passes. Hope you guys enjoyed this one. We'll see you in the next lesson.
So it puts the filter after. That should be inside main. I don't understand why this gives me. Yeah. Why does it not give me a number? call it plus 1. Yeah, plus equal. What's the difference? On these zeros, the thing that was missing on the other one. Right by count. Makes more sense. Because count is the variable that is accumulating the numbers of items. That it returns a new array containing only the square of only the positive integers. Square is up. Yeah. Oh, yeah. Small numbers are not integers. Parse int main. I'll be right back. Dot score. How can I do this? Element. The syntax is correct. So why is giving me that? it gives me undefined. Nice. for the books.
Hello friends, welcome back. Today we're going to use a higher order functions like map, filter, or reduce to solve a complex problem. Now that you've worked through a few challenges using higher order functions like map, filter, reduce, you now get to apply them to solve a more complex challenge. We have defined a function named square list. You need to complete the code for square list function using any combination of map, filter, and reduce so that it returns a new array containing only the square of only the positive integers. Decimal numbers are not integers. Only positive integers. When an array of real numbers is passed to it. An example of an array containing only real numbers is -3, 4.8 is an array with the numbers -3, 4.8, 5, 3, and -3.2. Your function should not use any kind of for or while loops or the for each function. Interesting. Okay, so if I look over here, it should be a function, square list. Okay, it's already a function, so I bet that would pass if we ran it now. This would probably pass, but we're not doing anything. We don't want to use while or for each loops. We should use, it says or, so that means we can use probably one or many. The function should return an array. Look at that, it's not returning an array yet. Well, yeah, square list, it's getting passed in an array and it's returning an array, so, and this should return 16, 170, 1,764, and 36. Square list should return 9, 149. Okay, so what do we really want it to do here? We have to find a function. You need to complete the code square list function using any combination of map filters so that it returns a new array containing only the square of only the positive integers. Decimal numbers are not integers. When an array of real numbers is passed to it. An example of an array containing, okay, so this is real numbers, but we want only positive integers. Okay, so the square of positive integers. So the positive integers here, 4 is a positive integer. 4 squared, so 4 times 4 is 16, 4, 8, 12, 16. So that's that one. This is not a positive integer. This is not a positive integer. This is not a positive integer. This is 42 times 42. 1764. Perfect. And 6. So we first off, we just want to filter the positive integers. And then we want to sum them each up. So yeah, I think that's the way to go. We want to filter, and then we want to map them by squaring them by themselves. So I think that's a pretty straightforward answer to this question. So let's get after it. First off, I would say let's let a result array is equal to here, and then we can return the result. I think that's a good way to start. That way we're not trying to manipulate the array at all, because that is against our functional programming background. And yeah, so here we can get rid of this now. I was just doing that because it's good to question assumptions early. Are we getting the square of those? That became clear, and that's what we're going for. And that way I was able to figure out what we're trying to do. Let's see, for this one, positive integers, I'm pretty sure these are all even, but does it care whether they're even or not? Of all positive integers, of only containing only the square of only the positive integers. Okay, so I'm thinking 3 times 3, yeah, 3 squared is 3 times 3 times 3, so 3, 6, 9. We basically want our result on this one to be 5 times 5 is 25, and 3 times 3 is 9, right? So we want our result to be, let's see, and then we'll refactor later. So this is the older way of writing the functions, and then we'll refactor it to error functions later. So how do you say that? If num, let's see, positive integer.
Tero e fibra é aproveitar.
I think that we could go like if console.log, let's say 10.2 is equal to parse int 10.2. Okay, that's false. But what if we were to pass in 10? That becomes true. No, but 03, that becomes true as well, so that doesn't work. So we want to find a way to find out whether or not triple equals parse int. Okay, so what I'm trying to find out is how do we find JavaScript, how to find out JavaScript if a number is a positive integer. Is integer. Oh, cool. Number dot is integer. So can we go number dot is integer? And then we can say 10. This should be true. 10.2. False. -10. False. Well, we know that. Okay, so we can do it two things. Okay, so if we can do both. No, if the number is an integer, and we want to pass in the number, not 10, and number is greater than 0, then we want to return the number. Well, otherwise we don't. Number is not defined. No, it's down there. I got the error. Number is not defined. Okay, so now we can get rid of this. We know what it is. Now what? Let's see. Let's just make our instead of returning the result, we can pass in positive integers. Okay, so yeah, that's it. And so now we've got all the positive integers coming out from here. -5 was filtered out, but 3, 10, and 7 all remain, and these are all derivatives of there. And so, yeah, well, actually, you know what we could do is we can just return number times number. No, okay, cool. So now we need to map it. So let's do that. So we go, actually, positive integers squared.
The same way.
Okay, so then we return positive integer squared. We get this. What we could do now is we go dot map, and we go function, and the number, and then we return number times number. Yeah, 9, 10, 49. Cool. So I think that this is the right answer. We can run the test. Nice, it passed. Okay, so there's probably a way to do reduce. There's probably 100 different ways to do this. Let's do a little refactoring. So first off, this could be an arrow function, and that'll make our code cleaned up a little bit more, right? This one also could be a arrow function, and that cleans up our code and makes it a little more modern. This is fine to be on one line because it's so short. Let's see here. What else could we do? This could be on one line as well because it's short as well. So yeah, already our code's looking much more succinct, even though I'm not sure if it's as readable as it was just a little bit ago. But you know, that's a decision that you've got to make. I guess this is, you know, we don't need the result variable anymore unless we wanted to make that. But I like naming them with, I'm a long variable name kind of guy. So if you don't like that, that's fine. A lot of this is just, this isn't necessarily the way that you have to do it or whatever. This is just how I think about it. I would probably refactor this down because positive integer squared is pretty straightforward, and I would use that as a function name. I would just basically remember that it worked in a function like this, and this is fairly readable once you get to a certain level. And yeah, I don't see any linting errors or anything like that. It looks a little crowded, but I don't know. I think that this is good. It definitely works the way we want it to. And so yeah, this is the refactored way of doing it. Yeah, do you even need the brackets in here? Yeah, okay, you do. Cool. Return the number, positive integer squared. I think that that's the best way to put it as well. So yeah, run the test and it passed. Hope you guys enjoyed this one, and I hope that I made it more explicit by talking the way through it. There's a lot of different ways to do this, so if you found a better one, that's great. Thanks for watching. We'll see you in the next lesson.
Sabia que com o novo app Meu Carrefour eu faço compras sem sair de casa e ainda ganho recompensas? Pois é.
Hello! In this video series, I will teach you how to do functional programming in JavaScript. In this first one, I will begin by telling you about
All right, if you've actually managed to sit through and watch all of these videos about all of these different functions, I'm kind of amazed. And really the truth of that, the point of what I'm doing is not to like, because there's a lot more of these array functions. Did I say this already in a previous video? But is not to go through all these one at a time and explain every single one, as useful as that possibly might be in some cases. But if you can kind of understand how they work and then figure out how to look up in the reference in the documentation, you can look at all the array functions and figure them out for yourself. But I'm here, let's do one more really useful one. Let's talk about sort. So I'm gonna come back over here. I'm gonna come back to this word stuff because we're gonna need that in a second. But let's just look at the let's just look at this array of vals for a second. So I'm gonna say console.log vals, and I'm just gonna say vals.sort with no function passed in and console.log vals. So let's see what happens. And let me give this the number 9. I'm gonna hit refresh, and we can see, look at that. It sorted it in numerical order from lowest to highest. That's ascending order. And in fact, it didn't make a new array. It sorted exactly that array. So this is important to realize. This is a distinction that we've really got to pay attention to. So far, in looking at these, filter makes a new array. Reduce doesn't make an array. Reduce takes down to a single. It could make an array, but that's a special case. Reduce and map make a new array. Fill fills an existing array, and filter and map, new array. Fill and sort act on an existing array. Reduce is a special case. So that's kind of important distinction between all of these. But how did it know to do that? Well, sort, you kind of like would say, like, oh, I sort. It should sort by numerical order. And if these were words, A, hello, B, goodbye, you would guess it's going to sort them in alphabetical order. Now, if this is capital B, that shows up first because it's actually going to sort by capital letters first. If there was something else that I was going to look at here, what was I going to say? Capital B. This is a special case. So that's kind of important distinction between all of these. But how did it know to do that? Well, sort, you kind of like would say, like, oh, I sort. It should sort by numerical order. And if these were words, A, hello, B, goodbye, you would guess it's going to sort them in alphabetical order. Now, if this is capital B, that shows up first because it's actually going to sort by capital letters first. If there was something else that I was going to look at here, what was I going to say? Capital B. If it's also like numbers and letters, it's going to first put the numbers and then in numeric order and then the letters in alphabetical order. So there's a default way that an array will be sorted. Now let's look at this case. What if I had just an array of objects? So what if my array was actually something like a bunch of XY pairs? So this is now an array, and I auto-formatted for me, of 2 objects, each with an X and a Y. Well, what if I sort that? Well, it didn't change the order. 5, 6, 2, 10. All right, well, let's be sure about this. Let's say 2, 10, 5, 6, and let's do it again. 2, 10 is first. Well, that's there. And now after sorting it, 2, 10 is the same order. So this is the thing. There is a default way of sorting stuff, but JavaScript, the sort function, only knows that default way for certain kind of obvious things, like numbers and strings. If you want to sort something yourself, you need to write your own comparing function. This is why sort is a higher order function, because it expects, the sort function expects as an argument a function which you could call the comparer or the comparator. That's not actually a word. I just feel like there's all sorts of goofiness in Java, these are long-winded, strange words. But you need to write a function that compares. And what does that function look like? So let's come back over here. So let's say for this particular case here, what I wanted to do is I wanted to sort this by the Y values. So I would write a function. I'm going to call it compare, and it's going to compare 2 elements. This higher order function requires 2 arguments, 2 elements of the array, and it's your job to say which one should go before the other. And the way that you can tell, the sort function to do that is by returning a positive or negative number. And I can never remember which is which, but positive maybe means A goes before B, negative means B goes before A, and 0 means they're equivalent, or it's the other way around. I would just try both ways, and eventually I figure it out. So for example, I could say return A.y minus B.y. Right, that makes sense, because in this case we're going to have 10 minus 6 is 4, or 6 minus 10 is negative 4. So if I put that compare function right here in vals, and I hit refresh, we're going to see that 6 comes before 10. Let's change this to B minus A, and we're going to see that 10 comes before 6. I know this is small, but can you see that? 10 comes before 6. So this, and if they're equal, right, that value is going to be 0. So what other ways can we have fun with this? Well, let's go back to this. It was a dark and stormy false night. I was trying to think with false. Let's put this back in here. And let's say what I did with filter in the previous video is I filtered out all of the words after I split up this text that were less than 3 characters. And let's just split up, let's actually, 3 or less. So let's make it 2 or less. So let's just make sure this still works. We can see, oh, vals is not defined. I'm going to comment this out. I'm not using that anymore. I'm just going to look at this code. And I'm going to see, OK, so that's my was dark and stormy night. Now, if I were to just say, right before here, words.sort, I would get and dark night stormy was. But what if I wanted to sort by the length of the words? So I would need to write a compare function. And so I could start doing this with function compare A, comma B, return. But here's the thing. I'm trying to use, as much as possible, this arrow syntax to be able to sort of inline right there, have the function that does the compare all in one line in a very condensed way. Let's try to do that. Maybe we've done it. I've done it enough times now that I don't need to write it first as a long-winded function, then make it an anonymous function, then an arrow function. Let's do it all at once. So I'm going to, this is very exciting. I'm going to say word. Oh no, so this is A, comma B, right? I always forget. So this is the compare function requires 2 arguments, 2 elements of the array that I'm going to compare. I'll keep this A and B sort of variable naming. It's totally arbitrary. I could call it cat and dog. Then I want to return the difference between the lengths. If one's length is bigger than the other, it should be after it. So I'm going to say B, and I don't need to say return. I'm just going to say B.length minus A.length. So this should give me now a way of sorting the array where the longer ones appear at the end. And let's see, I probably got this backwards. I always get it backwards. I got it backwards, of course, where the longer ones are at the beginning. So I could have figured that out, but in the end, I can just say A minus B. And then there we go. Was and dark stormy. So you can see 3 letter, 3 letter, 4 letter, 5 letter, 5 letter. So this is the way that you can sort. You can sort custom any list of any array of stuff based on however you want to compare two elements of that array. All right. Now, I'm trying to think if there's anything else I have to say. I think that's it. So we were done. We've gotten through all this stuff. What I want to do now is I want to look at taking a lot of these concepts into a kind of creative, classic creative coding scenario, a particle system, and using a higher order function to write a bunch of ways of managing, to do a bunch of things to manage that array of particles. And I'll do that in the next video, which you may or may not choose to watch. Thanks very much.
This gives me an theory. No, should work. Yeah. regex, man. Nice. Space and signs. So then you choose try. Oh, I should pass. Yeah. And the titles of a post that each part of the URL for simple bookmarking purpose. There is a hyphenated version of the URL. You can use any of the methods covered in the section, and then use replace. The output should be all lowercase letters. What's the difference between these two? Double space. Dollar sign. There we go. There we go.
A gente cansou.
Same thing I did, basically.
It's got spaces, that kind of thing. The output is a string with the spaces between the words replaced with a hyphen. The output should be all lowercase letters. The output should not have any spaces. Okay, full disclosure, I just ran through this one. The first time I did it, I wasn't able to get the global title variable should not change thing to pass. And then I reset the code, did it again, and I was able to get it to pass. So I'm going to do it again now, and hopefully we won't have that same issue. But the first thing I want to do is create a copy. So a title copy. And we're going to make that equal to title.slice, like there. And now what we want to do is return title copy, and I want to console.log winter coming. Why? Because winter coming is equal to the result of this URL slug function that we're working on in relation to global title. And so we see the title copy is actually, the title copy is the same as our global title. And so therefore, I think we're good to go. Our next step is, well, we want to go title, we could say, oh, well, we've already made a copy of it, right? So what can we do now? We've got it to say .slice, but now we could say dot to lowercase. And then winter is coming out in lowercase letters. That fulfills that part of it. And now we could also split it based upon the spaces, correct? I'm going to extend this just a little bit so we stay in there. We want to keep this on one line. Okay, so our title copy is now, we could call this a, well, this is actually more like the title divided into lowercase words. And then we pass this into there. So the title divided into lowercase words. And so our next step is to filter those words. Why? Because down here we're seeing winter is coming. Now if we passed this as the global variable, that was it. Okay, so what was happening was I was changing the global variable in the code here, and that was causing this to fail. And that's the first time that's happened. So that's going to be helpful. Anyways, let's pass this back in here and see what we're working with when we have a lot of interesting weird spaces. Now you see our array, our title divided into lowercase words, has a bunch of words that we don't want. So what do we want to do? We want to filter those words, right? So we want to say the title divided into lowercase words, we want to say filtered words. We're going to let filtered words equal title divided into lowercase words dot filter, and then we're going to say function word. And then we're going to say if word is not equal to empty string, then we want to return the word. So that means any words that aren't empty strings, we want to return. And now let's have our function return that. Cool, now we have a cleaned up array. And so we no longer need this funky one. Winter is coming is the same output as winter is coming. And so filtered words is there. And what do we need to do to filtered words? Well, we need to go dot join with a dash. Well, joint is not right, but we can join them. And so then we get winter is coming like this. If we run the test, great, they pass. Okay, so this is terrible. This looks just terrible, right? I mean, you think about it, all of this could be passed in just by concatenating the whole thing together, right? We could put this here, and that'll filter it just as well. And then we could also, yeah, we could actually put the title.slice in here as well. We could just take this whole thing, get rid of this, and put it here, filtered words. So we just want to return the title. .slice. We run the tests. That still passes. Now this kind of looks terrible. Now one thing that people do will say title, and you can kind of write it like this: title.slice to lowercase, split the filter. You keep the filter up like that, and then you increment this up. Oops. And then you add the dot join up here as well. You could actually do it like that. Now this actually passes all the tests as well. So this looks a lot cleaner, perhaps, if you like doing it like that. Yeah, I would probably do it like this. Another thing we could do to refactor is to use ES6 and the arrow functions. If word, return word. that makes it a little bit easier. We can put this on one line as well.
Right.
And so instead of having it like that, we can do it like this. This still passes the test. Now this actually looks pretty clean to me. The order of these is very important, right? Title.slice makes a copy. We take it to lowercase. We don't actually have to do that. We can take it to lowercase down here if we wanted to. And that would run and pass the test as well. So lowercase is sort of the one that isn't very important. Join definitely has to be after split, and filter has to be between split and join. And slice.
Wait, check if I can pass a particular test. There we go. Same thing. The first one's for every element. This one's for some elements. I wonder if it passes when we do that. Going function is convert to function and function to convert to one. Restructures a function so it takes one argument. Then returns another function that takes the next argument, so on. Structures a function so it takes one argument. always forget the curly braces. Maybe that's the problem. Right back. That's not a function. Now it should work. Yes. Okay. Return the sum of those two numbers plus the sum of all the numbers between them. The lowest number not always comes first. Okay. That's not the function I need. I need to check each one is the biggest one first. Maybe just use count outside. And do a normal for loop. That's not gonna work. Let's scratch that. No. Yeah, it's probably not the best way, but no. Yeah, it's not what I want. maybe it is what I want. Why is this giving me an error? Oh, that's why. Alright, that push is not a function. Giving me undefined. What's the other way? Yeah. So count equals 3. If I just do this, no. I'm gonna push the numbers are the difference. It's gonna start at the smallest number. And we can use reduce step. So this is going to create a variable with the minimum value and close me. It is not defined. No menu is defined. It's not gonna work. Let me try another way. Okay. It's gonna start from main and then advise push undefined. No, there we go. But I don't want the 0 there. That's the issue. Or the 1. See if I do it like this. The count should start at 1. That's the thing. There we go. +1 maybe. So I can remove the duplicates. Maybe here as well. Now I reduce. I think this is right. So why is it giving me 15? Why not that? So it's not pushing. So let's see, 5 is smaller than 10. So counts 10 minus 5, 5. I is gonna be 5. Yeah. I equals 5, 6. So why is not pushing the values? Because it's negative. That's why. No, 10 minus 5 is 5. That's not why. That's weird. Weird. Let me put this in the tutor. Fine. No, because I is bigger than the count. That's why. So this is the problem. Because I'm making the maybe I can create another variable here called max. Here, format this. And that way, yeah, there we go. We still have this problem here, which is that the I think now it works. Yes, there we go. Probably not the best way to do this. Definitely not the best way. At least I got it done. F.max.
Hey everybody, welcome back. Today we're going to do intermediate algorithm scripting. This is the sum of all numbers in a range. So basically we want to pass you an array of two numbers, and we want to return the sum of those two numbers plus the sum of all the numbers between them. The lowest number will not always come first. Okay, so that tells us that we need to differentiate between which number's higher and which number's lower. And then we could do a loop or recursion, but in this, I think a loop makes more sense because recursion's annoying. And if the range was really huge, the recursion would cause a stack overflow, and there's no reason to think that we're not going to be using like large ranges. So for example, sum of all 4 and 1 should return 10. Because the sum of all the numbers between 1 and 4, 1, 2, 3, 4. 1 plus 2 is 3, 3 plus 3 is 6, 4 plus 6 is 10. So we want to read search ask if you get stuck. Okay, so first off, we should just say it wants to return a number. Okay, cool. 1 and 4 should return 10. 4 and 1 should return 10. So we need to first off differentiate which one's the minimum and which one's the maximum. 5 and 10, 5 plus 6 plus 7 plus 8 plus 9 should be 45. And the same at higher numbers. Okay, so the first thing that we want to do is I'm going to be using a bit of Node. If you don't have Node set up, let me know in the comments and I might make a tutorial about this, and maybe a button just popped up to show you how to set up Node. The great thing about Node is that it gives you the opportunity to it's called a REPL. And so I want to be able to say like let's let my array equal 1 and 4. Okay, so if I go my array, I get 1 and 4. And now I think that so I'm just going to JavaScript my min. Okay, so if I look this up, if I go math min 5 and 10, this should give me 5, right? Because it says the bottom number. And then you can use max as well, and max will give you 10. So what we can do, if we have my array at that, we can do math.min of my array at point 0 and my array at point 1. This should give us, because it's my array is here, this should give us the response of 1. And if we change this guy to max, we should get 4. Okay, so this is how we can get that. So if we go back to this guy, what we can say is let minimum number is equal to math.min of array at position 0 and array at position 1. and then let max imum number is equal to math.max at array at 0 and array at 1. Okay, cool. So now what's going on is if we say if my array is equal to 1 and 4, we can set, you see what we're doing here is just saying we're assigning to the variable the minimum number. Ooh, I made a mistake. Okay, in this example, it's my array. Okay, it doesn't like that minimum number's already been declared. Oh, this is that difference between let. So with var, I can overwrite that. Okay, so I don't need to declare the new variable. I just need to set it to that. This is just part of the reference. Anyways, so what we've done is we've assigned the lower value. So it would be 1 in this case, it would be 1 in this case, it would be 1 in this case, it would be 5 in this case, and the maximum number to this array. And so then what we want to do is write a for loop for variable I is equal to the minimum number.
I didn't know about the
and then
math that
I is less than or equal to the maximum number. And then we want to increment I by 1. This will give us a loop that starts at the beginning and then ends at the end. So the smallest number is where it'll start, and then it'll go until the end. Also, we want to have a variable for the result. We want to set that equal to 0 because we want to start at 0. So we want to make the result equal to plus equal to I. So as it iterates through 1, 2, 3, 4, it's going to be adding that together. So it's going to start at 0, and then it's going to go to the first number, which is 1, so the result will become equal to 1. And then it's going to go to the second number, 2, so it's going to be 2 plus 1 is equal to 3. And then it'll be 3 plus 3, and then it'll be 3 plus 4, and that'll get us 10. And then we want to return the result. Okay, cool. So this worked. Now I'm going to take this over to the console, or to my Atom window, where I can run tests on this. And I'm going to put in here console.log I, and then the result. And I'm actually going to add in here I, and then add in. The reason I'm doing this is just to show you how it works. So now I can press Command I and run this function. Oh, it didn't happen because I need to actually sum all of the array, and then make it. Let's go 10 to 15. Okay, cool. So 0, we start off at 0, which is the result, and then we apply 10. And then 10 plus 11, 21. 21 plus 12, 33. 33 plus 13, 46. 46 plus 14, 60. 60 plus 15. And then if we actually console log the result of this, we'll get the resulting number. 75. So the answer of this, all the sum of all the numbers between 10 and 15, including 10 and 15, is 75. That's pretty awesome. As you can tell, like you can do 150 here and actually get a giant number, right? The sum of all the numbers, including 10 to 150, is 11,280. And you can do that really quickly with algorithm scripting. And so that's why this stuff is so interesting and powerful. But as you can tell, this is how you pass the test. This is one way to do it. There's a million ways to do it. I'm sure there's more efficient ways to do it. But I think that this is just a simple way to sort of figure it out. And so yeah, that's it. Hope this helped you guys. And I'll see you in the next lesson.
Okay, so I'm going to concatenate them and then split if there's a difference. Let me see what this does. can I... So this doesn't do anything. Use map as well. The map should be easier, I think. New wires on function. This is not gonna... We can use reduce. Here's gonna be new. How can I remove them? That should be return. Filter maybe. Let me bend this guy real quick. I think All right. Okay. Maybe filter is better for this. Filter. Maybe. How does this doesn't work? No, I know what should do. No, that doesn't work. Probably it's gonna be a different value, but I'm gonna take the ones that are equal. That's the issue here. Maybe if I sort first. Now it works. Maybe a for loop. I wanted to use these new methods, but I don't think I'm gonna be able to do it with the new ones. Oh, the issue is there are strings also, not just numbers. No problem. Problems that they are different. In size. Be right back. feel like I should use filter or something like that. And the sort. Oh, forgot about this one. maybe this is the right one. No, but it's not gonna work because there are strings in some of them. Yeah. That's a good idea. Oh no, never mind. I'm gonna say choose map to divide everything by the number. But then I forgot that it would give me a lot of them that's not equal to 1. don't think this is gonna work. I'll go ahead and see if it contains or not. Yeah. I'm gonna look for this. I'll be right back.
Qual que é o nome dele, deixa eu saber? É um sanduíche só.
Pode chamar. The number from the new merged array. I think I know what I'm gonna do. How it works. Let's see if this passes. Not returning string. That's not the problem. I don't understand why this is wrong. What if I do this? Maybe we should do the other way around also. No, it's simpler. This is wrong. Let me find this thing, please. No. I don't know. I'm gonna look for the solution. I'm just gonna look for the see something. Of course it's gonna contain all of them, because I just concatenated them. Yes, yeah. Maybe if I do the opposite way. No. R2, another one. I think it's gonna do any difference though. So the 4 is not there. Maybe map instead of filter. Here is equal. So y is not doing the opposite way. Maybe. No. Maybe if instead of returning, just pop. Yeah, but then maybe I just don't need this thing. It's doing the opposite of what I want to do. Let me see if I can understand this on Python. Maybe if I create another array here, and then it's gonna push a bunch, and the for is not there still. Because it's only filtering array 1. Yeah. This doesn't work because it's gonna have all of them. Merge the list to make it easy to compare functions. Use filter to get in your array. You need to create a callback function. Best way to go about the callback function is to check if the number from the new merged array is not in both original arrays and return. Number from the new merged array. Now how do I do this? I'm gonna check to see if it's not in both. Okay, create a variable outside to see which one has a bigger length and then put it here to loop through the whole thing, but I don't want to do that. How do I backspace them? There we go. Shift tab does that. Yeah, I don't know. I'm gonna look for the solution. Okay, so this is not the solution that includes the hint. No exclamation mark includes icon. But why or and not and? Includes. Still not giving me the answer. Maybe this is wrong. No. Explanation. Yeah, doesn't make sense. And because this is saying that it doesn't include on both of them together. What if they are the same? then it gives me an empty. Yeah, that makes sense. Maybe the guy didn't do it for this one. Useful programmer. You have to use the arguments object. What does that mean? This is an easy one, I think.
Do array 2. So we're going to check to see if the index of array 1 at position I is -1. What does that mean? That means we're going to first say this position is direct a in here. What's the index of direct in this array? And this one it's going to say 1. And it's going to continue to do that. Here it's going to be 2, here it's going to be 3, here it's going to be 4. No, here it's going to be 0, 1, 2, 3. And then when it gets to pink wool, the index of that is going to be -1. And so therefore we want to add this to our new array. So we're going to say array, we're going to push it to the new array. So new array dot push array 1 at position I. Cool. And so this is working for this purpose, but that's only because in this example we have pink wool being on the first array and not the second array. But what happens if we were to put pink wool in the second array? Then it wouldn't work, right? So what we need to do is just basically do this again. So we're going to say we let j equal 0, j is less than array 2 dot length, and then j plus equals 1. A successful answer for this problem. Okay, cool. But one of the things, let's refactor a little bit. Yeah, I mean, we could, this is a duplicate function, right? We're repeating ourselves by adding this function in here twice, and that is sort of annoying. So what if we could write this into a function and then just compare them? We could say function compare arrays. Compare against other. Okay, and then the first and the second. And now we've got the function. Let's just get rid of this for now, and we can repurpose it to fit here. So I is equal to 0, and then instead of array 1, we say first. And then here we say second. And then, now that we have a function, compare against other, we can just run this twice. And then go second and first. So it'll automatically first and second, first and second. Oh, instead of passing in first and second, we go array 1 and array 2, and then we go array 2 and array 1. Okay, cool. So now we're only writing this for statement once, and we're reusing this function. And that's pretty cool. This is pretty useful because what we're doing is we're just passing the parameters in differently, and so that's pretty cool. Another thing we could do is do a for each, which would make this a little bit more succinct. Again, this isn't entirely important, but we could go first dot for each, and then we go function, element, or we can go number, and then we say we do that one, right? And instead of saying here with the first dot I, we can go number. And then number. We don't need to use I. So now we've got a for each function, which functions the exact same way. So we've just refactored it to do it another way. So first off, we've dried up the code by writing the function only once, and then we've just compared it against each other. But we can take this even further, right? Because we know we can make this an ES6 arrow function, which would tighten it up a little bit more. We run the tests. That still works. We also know that we can do a statement like this. We can put this on a single line, and that gives us the pink wool as well. So that's kind of helpful. How else can we refactor this? Let's see here. Well, we could also use higher order functions and things like that, like a filter type thing. Maybe put both of the arrays together and then filter any duplicates.
So that's
I'm not sure if we really need to do that for now, because I think that this is a pretty good way to, I mean, first off, we've gone through a bunch of different ways to do this. I think conceptually it makes sense. You know, you just iterate through each array and you find out if there's anything that's not included as part of the other, and that's how you get the symmetric difference. Here we've got pretty dry code, and initially the code was really explicit, but as we've refactored it, it becomes a little bit more hard to understand, but I think that that's kind of useful. And so, yeah, I'm just going to stick with this one for now. Run the tests. I think they pass. Okay, hope you guys enjoyed this one. We'll see you in the next lesson.
I don't see the point in this exercise. I don't see how to use. I don't know how to use this arguments object. Just like this. Yeah. So many fucking ads.
How's it going, guys? My name is Dom, and today I want to talk about the arguments object in JavaScript. So basically, the arguments object allows you to access all of the arguments that are passed into a function with an array-like syntax. So you can actually access these arguments using indexes. So, for example, let's just say we define a new function in JavaScript and call this one body. Okay, this function will take no arguments, just for now, right? In the parameter section up here. Now in the body, let's just console.log. Inside here, let's pass in the console of the browser. We should see DOM. Let's just save this and refresh the browser real quick. And we get DOM right there. So what's happening is we're accessing the arguments property, or the arguments local variable inside this bottle function. And this behaves like an array, so you can actually access the arguments passed in by index. So index 0 is the first argument passed into the function. So if I also change this to index 1, save and then refresh the browser, we now get undefined right there because we haven't actually passed in 2 arguments. If I was to pass in an argument such as 6 inside here, save and refresh, we now see 6 in the console. So you can see how you're sort of able to access an arbitrary amount of arguments through this arguments object. Okay, it's even got a length property. So if I also just console.log and then you get rid of this and say .length, we now should see 2 in the console. Let's save and refresh, and we get 2 right there. So we get 2 because we have passed in 2 arguments to that function. Now, this can be useful, obviously, in situations where you're unsure of how many arguments to actually expect in the function body. And it's useful when, I guess, creating libraries or helper functions. Alright, so, for example, let's create a function called sum, and this will spit out the sum of a bunch of numbers passed in. We'll type that function, call this one sum, take no parameters or no arguments. Now, in the actual body, let's loop through all the arguments and then return the sum. So, let's create a new variable here and call this one sum equal to 0 for now. Inside the, or I guess down here, let's create a loop. So, we'll create a new, make a new for loop. I equals 0, I less than arguments dot length, alright, I plus plus, and then we can just say sum is plus equal to arguments at index I, and then we can just return the sum right there. So now this function is going to support an unspecified amount of arguments, and then add all those together and return the result. So let's create a new variable down here and call this one total equal to the return value of this sum function, passing in some numbers such as 10, 20, and 4. So now total should equal 34, 10 plus 20 plus 4. Let's just console.log total and see how we go. I'll save and refresh this, and what we get 34 right there. Alright, and that's how you can use the arguments object in JavaScript. Thank you for watching, and I'll see you later.
Let's see what's going on. The problem is that I have to push only the values that are different. So the values that are the same they are the same value as their arguments. Index of, yeah. Let's try includes. Why is saying fine? Maybe I should. It's because not an array. Yeah. Now it's returning empty. What was the way that it was done on the previous one? Because I know it was something like this, but some shit like this. Interesting. Yeah, I don't know. Let's see what time is it. Okay, well, 23 minutes here. Nice. Now I think so. That's what I don't understand. It's the same logic as the other one, but I don't remember. I don't understand that logic. Doesn't contain. No, it's not. The file is not. It's order factors. No. I'm gonna look at the solution. Yeah.
Hello everyone, welcome back. Today we're going to do one called diff. We're only writing this for statement once. Got a for each function, which functions the exact same way. So we just refactored it to do it. Do that for now because I think that this is a pretty good way to, I mean, first off, we've gone through a bunch of different ways to do this. I think conceptually it makes sense. You know, you just iterate through each array and you find out if there's anything that's not included as part of the other, and that's how you get the symmetric difference. Here we got pretty dry code, and you know, initially the code was really explicit, but as we refactored it, it becomes a little bit more hard to understand. But I think that that's kind of useful, and so yeah, I'm just gonna stick with this one for now. Run the test. I think they pass. Okay, hope you guys enjoy this one. We'll see you in the next lesson.
É, não. Tem que mudar uma coisa. Puxa. No, I have 5, but no. Don't have 1. 0. Yeah. But it shows up 2 times. Let's see how many this passes. Oh. That's why. Why is pushing everything? Let's see how much time I got. 8 minutes. here. I think I don't understand this arguments thing. I think I'm just gonna look to the solution and then I'm done for today. yeah. Okay, I'm done for today. I will come back another day. See you.